Hello, beautifuls. This is Atleen, and I'm coming to you with another video. And today we will be discussing introduction to TCP, IP, transport, and applications. As we discussed yesterday, network fundamentals. And so today we will be discussing compare TCP to UDP. And once we get done with the readings, we will go over, do I know this already? And with this chapter, it has 1 through 6 and a few questions regarding comparing and contrasting UDP and TCP. Okay, so I'll start reading. The OSI transport layer, layer 4, defines several functions, the most important of which are error recovery and flow control. Likewise, the TCP IP transport layer protocols also implement these types of features. Note that both the OSI model, which is what we went over yesterday on the whiteboard, and the TCP IP model call this layer the transport layer. But as usual, when referring to the TCP IP model, the layer name and number are based on OSI. So any TCP IP transport layer protocols are considered layer 4 protocols. And please note that the key difference between TCP and UDP is that TCP, transmission control protocol, provides a whole variety of services to appliances, whereas UDP is in its own category, and it may not do the same things that TCP does. So let's look at the features of each one, UDP as well as TCP. UDP functions is that it provides multiplexing using ports. And this is a function that allows receiving hosts to choose the correct application for which data is destined based on the port number. TCP has error recovery, which is reliability. UDP does not have error recovery. And with this process, it's a process of numbering and acknowledging data with sequence acknowledgement header fields. TCP has the feature of flow control using windowing. And this is the process that uses window sizes to protect buffer space and routing devices from being overloaded with traffic, as you can see in the table. UDP multiplexing using ports. TCP has this as well. TCP has error recovery, which is reliability. TCP has flow control using windowing. TCP also has a connection establishment and termination, whereas UDP does not have this. is connectionless. And connection established and termination description is process used to initialize port numbers and sequence and acknowledgement fields. TCP has ordered data transfer and data segmentation. Continuous stream of bytes from an upper layer process that is segmented for transmission and delivered to upper layer processes at the receiving device with the bytes in the same order. So with UDP, it does not perform error recovery, but it takes less bandwidth. So that is a benefit, and uses fewer processing cycles. And that's also a benefit of UDP. So regardless of which of these two TCP IP transport layer protocol the application chooses to use, you should understand the basics of how each of these transport layer protocol works. Now with the CCNA exam, you will come across a variety of TCP IP applications, and you should at least be aware of some of the applications that can be used to help manage and control a network. That's what's going to be on the CCNA exam, most likely. If it's going to be multiple choice or drop and drag, more than likely what's going to be on there is popular applications and their well-known port numbers, which is shown here in table 1-3. Port number 20 protocol is TCP. FTP data is the application, and it's a file transfer protocol. Port number 21 is TCP. Application is FTP control, file transfer protocol. Port number 22 is a protocol of TCP, and the application is SSH, secure shell. Port number 23 is protocol is TCP, and the application is Telnet. Port number 25 is TCP, that's the protocol, and the application is SMTP, Simple Mail Transfer Protocol. Port number 53 protocol is UDP and TCP. The application is DNS, Domain Name System, and the domain name system allows users to use names to refer to computers, with DNS being used to find the corresponding IP addresses. Port number 67 protocol is UDP, and the application is DHCP server, Dynamic Host Configuration Protocol. And 69 is the port number. Protocol is UDP. Application is TFTP, Trivial File Transfer. And Trivial File Transfer defines a protocol for basic file transfer. Port number 80, TCP is the protocol, And the application is HTTP, the World Wide Web. And this application exists through web browsers, accessing the content available on web servers. Although it is often thought of as an end user application, you can actually use www to manage a router or switch. You enable a web server function in the router or switch and use a browser to access the router or switch. The next port number is 110.110, and the protocol is TCP, and an application is POP3, Post Office Protocol, version 3. Both used for transferring mail, require guaranteed delivery, so they use TCP because, again, as we said, UDP is not reliable. It has no reliability. Okay, so I would like to go over the three-way handshake. The three-way connection establishment flow, also called a three-way handshake, must complete before data transfer can begin. The connection exists between the two sockets. Although the TCP header has no single socket field, of the three parts of a socket, the IP addresses are implied based on the source and destination IP addresses in the IP header. TCP is implied because a TCP header is in use, as specified by the protocol field value in the IP header. Therefore, the only parts of the socket that need to be encoded in the TCP header are the port numbers. TCP establishes and terminates connections between the endpoints, whereas UDP does not. Many protocols operate under the same concepts, so the terms connection-oriented and connectionless are used to refer to the general idea of each. More formally, these terms can be defined as follows. Connection-oriented protocol, a protocol that requires an exchange of messages before data transfer begins, or that has a required pre-established correlation between two endpoints. Connectionless protocol, a protocol that does not require an exchange of messages and that does not require pre-established correlation between two endpoints. So as we discussed earlier, let's go to the definition. As you can see, UDP is a user datagram protocol, connectionless transport layer protocol, is the TCP protocol stack. UDP is a simple protocol that exchanges datagrams without acknowledgments or guaranteed delivery. So as we discussed earlier, UDP is connectionless and it doesn't require a acknowledgement. Whereas with TCP, is a transmission control protocol, internet protocol, okay? Transmission control protocol, a connection oriented transport layer TCP IP protocol that provides reliable data transmission. So as you can see, it requires a acknowledgement, ACK, which is what we discussed. All right, so let's go to do I know this already quiz. And in regard to what we discussed, which of the following functions is performed by both TCP and UDP? And we already know that UDP is limited on their features, but they do have good features such as less requirement of bandwidth, less bandwidth required. Because they don't have a acknowledgement, we can use it as a voiceover. We use it as streaming the internet, things of that nature. Whereas TCP has more features such as windowing, error recovery, routing, encryption. So the answer is multiplexing using port numbers, because TCP and UDP does both of those. Which of the following are typical functions of TCP? And we read this earlier. So the typical functions of TCP are flow control, windowing, error recovery, multiplexing using port numbers, order data transferring. Which of the following header fields identify which TCP application gets data received by the computer? So that's going to be TC port number and UDP port number. All right, so we went over a little bit of 18 minutes. This is just the network fundamentals of comparing TCP and to UDP. And we're still going over the OSI model. This is going to be the networking model, TCP IP, and the networking model, sometimes called a networking architecture or networking blueprint, is basically what we're going over for the next couple of days. Okay, so thank you for watching. Thank you for listening, and I wish you well.